Assalamualaikum, my name is Muhammad Amirul Afiq. Today we present about I'm from Group 17. Today we present about grid connected solar photovoltaic system designed in Ottawa, Canada. Introduction: Grid connect photovoltaic system is the most common applicable around the world. Grid connected photovoltaic systems have many issues to be considered before being installed. Before installing photovoltaic system following Malaysian standard, there are several parameters need to be identified and analyzed, such as type of panel, temperature, solar radiation, output power, and lastly performance ratio. All these aspects need to be analyzed first to ensure the system are fully utilized and working well. Installing grid-connected photovoltaic system need a huge amount of cost. This is including the cost of the component in the system such as panel, inverter, protection, surge device, and cable. Economic aspects have to be investigated first to ensure the system is not a loss due to unable to use it for a long period. Because of that, the system need to be analyzed for using software to ensure return of the investment for this project just as early as planned. Next is a background study. This project located at city of Ottawa, Canada with a map of 45.396951 latitude and negative 075.685159 latitude that have four very distinct seasons as a winter, spring, summer and fall. Ottawa have annual average direct normal radiation of 1470.1 kilowatt hour per meter square per year in 2022, and monthly average direct normal radiation that show July monthly have the highest solar radiation because of the summer season that have around temperature reach 80 Fahrenheit between the overall month shown in figure. PV outlet of Canada have annual of the total potential around 14,000 kilowatt per hour kilowatt per to 15,000 kilowatt per hour. It can conclude that Canada residents need to take change of the implementing the solar PV system because of its high potential renewable system. Next is to design the problem of the system. As known, PV array is a main component in grid-connected photovoltaic system. The PV array built from PV cell then combined to be model as shown in figure 4. PV model use process that convert sunlight absorbed from the sun into the electricity at the atomic level. So this is our design. This is a design from the problem statement. Next is choosing an inverter for energy conversion. Power conditioning unit (PCU) are the most significant component in the photovoltaic system because they manage the DC electricity generated by the array and convert it to the high quality AC power. PV system can be compared based on the number of the processing stage, single stage and two stage system. In a single-stage system, an inverter performs all of the needed PV system controlling activities. A DC-DC converter process in the controller and the inverter divide into two inverters in a two-stage system. Inverter choose capacity must not exceed the generation power in PV array that can affect the performance of inverter. Next is a tilt angle of the PV array. Tilt angle is the setting of the panel. One need to have the maximum radius. Ideally, the tilt angle is the latitude of the geographic location. It suggests to have an adjustable panel frame as the sun hour keep changing with respect to the tilt in winter and summer. Hence, for any arca, a specific tilt angle calculate to get the maximum radius throughout the year for fixed panel. As shown in the appendix, the optimum tilt of the PV panel recommended is a 38/180 degree. Next is a panel sizing. Once the total load to be energized during using the PV system is calculated, we must find out the watt area of the solar panel would be required to generate that much of power. It is an inherent property of any panel to have internal losses. This factor should be kept in mind. As in the energy calculation, we have already found the total watt hour. For finding the wattage of the panel that will be required, need to divide the total watt per hour with peak sun hour. Next is a meteorological data analysis. The daily sun irradiation, daily lowest temperature, and daily maximum temperature and daily average temperature are measured and recorded. So bear in mind the latitude of the Ottawa, Canada is a 45.4215. So this is one of the sample uh, temperature minimum and max. Sample of data from 1st January until 31st December 2021. The average monthly temperature and sun radiation may be calculated after the whole table has been filled. The average temperature of each month shown by dividing the data table by month. It is also determined by average the whole column of solar radiation. So the table here show the RS average of every month and the temperature average also for every month. The PSH value may now be determined by dividing daily solar radiation by 1000 watt per meter square once the monthly solar radiation data has been finished. For instance, the PSH for January is 1.48 hours, whereas the PSH for February is 2.59 hours. There are 1417.16 hours total peak sun hours in Ottawa, Canada per year, which is 3.88 hours per day average over cost for 1 year. This is a residential daily load profile. Residential load data from Ottawa, Canada is required in order to construct a PV system. As a result, some online research is conducted to determine which electrical equipment are most typically found in Ottawa, Canada home. In order to keep track of the daily energy use of the appliance, an audit checklist was established. Ottawa, Canada residents are predicted to use 90.58 kilowatt energy each day and 33,065.36 kilowatt hour per year. So this is the appliance that we use in residential: fans, dryer, washing machine, refrigerator, microwave oven, computer, air conditioner, television, and light. Design of proposed PV system. Resin Solar RS350P 72 polystyrene 360 watt PV module and Huawei Sun 2023 KTL 28 kilowatt inverter both installed in this design. These two tables show the PV module specification parameter and also inverter specification parameter. Now is shows two picture of. First is a arrangement of solar PV panel, and next is a single line diagram of the project. So for optimal size inverter, the number of panel is 13. So 678. So this is the suitable inverter that we use, solar panel arrangement that we use. Next is this system component are 78 pieces of PV model of 1 piece of inverter. From the table, the PV system capacity design is 28.08 kilowatt. The price of each 1 kilowatt is 71.3 Canadian dollar, which in Malaysia ringgit is 242.58 ringgit. From the website, PV model and inverter design, the price of each PV module after convert in ringgit Malaysia is 322.41 and will be multiplied by 78 pieces that the total cost of PV module need in this system is 29,827.98 cents, while each inverter price is about $200, or in Malaysian ringgit is 8,852. Assume the total installation cost is 5,000, so the total installation cost is 43,679.98 ringgit cent. So by that we can calculate the ROI, and then the total ROI is 6.1 years, around 7 months. And discussion. In the design of a small scale 28.08 kilowatt rooftop grid converter solar photovoltaic system in Ottawa, Canada, for the entire year of 2021, the daily solar irradiation average temperature, daily minimum temperature, and the daily maximum temperature of the observer and are recorded. The annual of total power potential around 14,000 kilowatt per hour to 15,000 kilowatt. The PSH for January is 1.48 hours, where the PSH for February is 2.49 hours. There are 1,417.60 hours of the total peak sun hours in Ottawa, Canada per year, which is 3.88 hours per day, average over the course of 1 year. Residential load profile in Ottawa, Canada. Residential profile of Ottawa in Canada are estimated to use 90.58 kilowatt hours per day and 33,065.36 kilowatt annually. PSH in this case are set to be 3.88 kilowatt per hour, which translates to 1,417.60 kilowatt per hour annually. The maximum power temperature coefficient for the PV model is a negative 0.40%. The calculation that show the maximum of 480 units can be arrayed horizontally, and 512 unit is designed arranged vertically. Based on how many module house need, only 12 are drawn in the interpret result. In anticipate, the required total of roof surface will be around 23.32 meter square, and the PV weight, which made out 12 unit PV model, is 264 kilogram. And lastly, for the conclusion, the design of grid connect PV photovoltaic PV power system for a resident in Ottawa, Canada has been presented in this paper. Both PV model and Huawei inverter use are this design, and ROI is calculated to estimate to be 6 years and 5 months to help the investor understand the project financially viability. And lastly, the design grid connected PV system is readily deployed and attached to the rooftop of the resident in Ottawa, Canada, to produce renewable energy after all necessary meteorological and data analysis, configuration, daily load profile, PV system component, sizing, and economic evaluation is calculated. That's all from me. Thank you.